Hello, my dear students. I hope you all are doing well and you are doing fun with your physics. You're watching my channel SmartGen20. Subscribe my channel, press the bell icon so that you could get the notification of my latest videos. If you are new to this channel, please subscribe and check the previous videos so that you could understand this video lecture. Please write down your comments and reviews in the comment box so that I could upgrade my lectures as per your desired level. Yet we have completed the basic terms, reflection and its laws, plane mirrors, deviation, and we have did couple of numericals. So without wasting your time, let's jump to our next topic, which is spherical mirror. Here I have already drawn a sphere which is having a center here. If I will put a sphere in front of this board, you will see that from the front view it will look like a circle like this. And when I cut a section from the sphere like this, I will get a section like this. And this section is actually called the spherical surface. And when this spherical surface is coated either sides, it is termed as spherical mirror. So I can define the spherical mirror. It is a spherical surface coated either side and is being cut out from a hollow sphere or hollow spherical glass. This is the definition of spherical mirror. Moving further, this spherical mirror is of two types. One is concave mirror and another is convex mirror. When I take this section and I coat its outer side and expose its inner side with the light rays, it is said to be the concave mirror. And this is the concave mirror. What about the convex mirror? When I take a section and coat its inner side and expose its external surface with the light rays, it is said to be the convex mirror. So, what is a convex mirror? What is a concave mirror? These are actually the spherical sections or spherical surfaces whose outer side is coated and inner side is exposed to the light rays is known as concave mirror. For convex mirror, it is the spherical surface coated inside and exposed its external surface to the light rays is termed as convex mirror. Now, by clearing the basic definitions of spherical mirror and its types concave and convex, let us move to the next topic, which is the terms related spherical mirror. And what are these terms? These are center of curvature. Here I have drawn a sphere, and when I cut it a section from this hollow sphere, it will look like this. And here this center would be here. And this center is called the center of curvature. Actually, this center is the center of the hollow sphere from which this spherical surface is cut out. So we can define this center of curvature is the center of hollow sphere of which our spherical mirror is a part. So this center here will be called center of curvature. Clear? Now second term is pole. What is a pole? If I will mark a point here on this reflecting surface and represent it by the letter P, it is represented by letter C. This point will be the midpoint of this reflecting surface. What it means, this point will be the midpoint of this reflecting surface. And sometimes we join these two ends, and this dotted line is called effective diameter. Because in practical you may have seen that these either concave mirror or convex mirror are not so much bulged in, because you may have seen this dotted line will be so nearer to this curve, it will seem like this is a plain piece of glass. You may have seen on our in our cars that we cannot find it is bulged in. It looks like a plain mirror. That's why we call this reflecting surface as effective diameter also. So I can define this pole. It is the midpoint of the reflecting surface or effective diameter. Some books write down effective diameter and some books write down a reflecting surface. So without getting confusion, this reflecting surface and this effective diameter are actually this reflecting surface. So Moving to the next term, which is principal axis. And what is a principal axis? If I will join these 2 points by a line and will produce them from both sides, this line would be called principal axis. So by defining the principal axis, it is actually the line joining the pole and center of curvature produced. Moving to the next term, which is radius of curvature. Radius of curvature. You are observing that this is a sphere and this point is its center. If I will draw any line from this center to the circumference of this circle, this would be called the radius of the sphere. Likewise, from this point to that point, this is also the radius denoted by capital R, and this radius is actually called the radius of curvature. So what is a radius of curvature? It is the radius of hollow sphere of which our spherical mirror is a part. Moving further, if I will mark a point here, let this be the radius of curvature denoted by R. If I will mark a point here and denote it by F, this F is actually called the focus. Focus of the spherical mirror, or simply focus. To define this focus, it is actually the point. If I will draw a spherical mirror here and I will incident some rays parallel to this principal axis, these rays will be reflected to a common point, which is actually the focus of that spherical mirror. So we can write down it as definition. It is the point on the principal axis on which or through which all the parallel rays with the principal axis it is the point on the principal axis on which or through which all the parallel rays with the principal axis will be reflected will be reflected or seems to be diverged. Here I said that seems to be diverged. It is the case for convex mirror. Because for a convex mirror, if I will draw here convex mirror, if the light rays are incident parallel to the principal axis, they will be reflected in such a manner so that they will seem to diverge from a point which will called the focus of convex mirror. Here concave mirror. And this focus is represented by letter F. Now we have defined the pole, we have defined the center of curvature, we have defined the radius of curvature, we have defined the focus. Now this part. This reflecting surface is called the aperture. Actually, aperture is of two types. One is linear aperture, which is actually this. Linear aperture, we mean this reflecting surface or effective diameter is called the linear aperture. We can say that a reflecting surface or effective diameter is termed as linear aperture. One more type is angular aperture. And what is angular aperture? It is actually the angle subtended at the center of curvature theta. So you can define this angular aperture. It is the angle subtended at the center of curvature by the endpoints of the reflecting surface. I think this is the all terms we have learned here or discussed. So moving ahead for our next topic, that is rules for drawing that is rules for drawing the image formation on the spherical mirrors. And what are those rules? Those rules are: number one, all the distances are measured from the pole. It is also mentioned in the sign convention, which we will again discuss in the sign convention later on. All the distances are measured from the pole. Means if I will draw here any spherical mirror, this will be the principal axis, this will be the pole, this will be the focus, this will be the center of curvature, and this will be the aperture or reflecting surface. And all the distances are actually measured from the pole. What it means, actually we are taking pole as our origin. If you have to measure the focal length of concave mirror or convex mirror, or you have to find out the object distance, image distance, you have to start from the pole of the mirror. You cannot measure from center of curvature or focus of the mirror or any other point. You have to come to the point which is called the pole, take it as an origin, and then start to measure any length. Rule number second. Any ray coming parallel to the principal axis are reflected in case of concave mirror or seems to diverge in case of convex mirror through the focus of spherical mirror, either concave or convex. What it means here, I have to rub this. Here you can see, if I will draw a concave mirror or convex mirror, both are having principal axes like this, both are having pole like this, both focuses and center of curvature. What this rule says, if any ray coming parallel to the principal axis, any ray coming parallel to the principal axis, any ray coming parallel to the principal axis, this is concave, this is convex. The ray will be reflected through the focus. The parallel rays will be reflected through the focus. In case of convex mirror, the incident ray will be reflected in such a manner they will seem to meet at a point which is focus, or it will seem like they have diverged from the focus. Diverge means it will seem as they have come from the focus, which means diverge from the focus. This is rule number second. Now, rule number third. Rule number third is saying any ray coming through the focus in case of concave mirror or seems to converge in case of convex mirror will be reflected back parallel to the principal axis. What it says here, if I again make convex and concave mirrors, this is pole, focus, center of curvature, focus, center of curvature. Any ray which coming through the focus. What it means, if any ray is incident through the focus, any ray coming through the focus, it will be reflected back, it will be reflected back parallel to the principal axis. Means if this is the principal axis, these reflected rays will be parallel to the principal axis. In case of convex mirror, you may see any ray seems to converge from the focus, which means any incident ray will fall like this. It will seem like it will converge on the focus. Likewise here it will seem as it is going to converge at the focus, will be reflected in such a manner that a reflected ray will be parallel to this principal axis. This is convex, this is concave. I hope this is clear to you. Now, rule number 4 or last rule is that any ray fallen to the pole of the spherical mirror, either concave or convex, it will be reflected back symmetrically. So, if here I will draw a concave mirror, a convex mirror, this is principal axis, this is principal axis, this is pole, focus, center of curvature, pole, focus, center of curvature. Any ray fall or coming to the pole like this means these rays are incident like this sorry, this incident ray is fallen to the pole, it will be reflected back symmetrically. Likewise here, if any ray fallen to the focus will be reflected back symmetrically. What mean by symmetrically? If this is the incident ray, the reflected ray will be the exact mirror image of this incident ray, same as here. These are the all four rules which we will require when we will draw the image formation on spherical mirrors. I hope all these rules are clear to you. So, jumping to the next topic, which is sign convention. For the sign convention, for spherical mirrors, we use Cartesian sign convention. Here again, which have already mentioned that pole is taken as origin. What it means? From spherical mirror, either concave or convex, if I have to measure any distance, I have to measure it from the pole. I have to take this pole as my origin. I cannot measure any length from any point, whether it is a focus or center of curvature. I have to take this pole as my origin. In the both cases, whether it is a concave or convex. So this is the first sign convention. Second sign convention is that any ray incident on spherical mirror no, we will discuss it like here, like this. Second convention is that all the measurements are taken positive. All the measurements are taken positive in the direction of incident ray. What it means? It means if I have a spherical mirror, this is the principal axis, this is the pole which I have to take the origin, this is the focus, this is the center of curvature. If incident ray is coming like this, and in case of convex mirror, which I will draw like this is concave, this is convex, this will be the principal axis. Here, this will be the focus, this will be the center of curvature. If incident ray is coming like this, What it mean? All the measurements are taken positive in the direction of the incident ray. What it means, if I have to measure, if I have object here and I have to measure the object distance, which is denoted by u, what will be the sign of the u? The sign of the u is negative, because all the measurements are taken positive in the direction of the incident ray. If I am having any image behind the mirror, which comes case when we put any object here, if I have to measure the image distance, it is coming from pole to this point in the direction of the incident ray. This image distance is taken to be positive. So I can add it here that all measurements are taken positive in the direction of the incident ray, and the measurements in the opposite direction of incident ray are taken as negative. So we can conclude here that any measurement in the direction of the incident ray are taken as positive, and in the direction opposite to the incident ray are taken as negative. What means, if I have to measure this object distance, I have to measure it from the pole. So my direction of the measurement will be like this, which is completely opposite to the incident ray. So I have to take this object distance as negative. Likewise, if I have to measure this image distance, my measurement direction will be like this, and which will be same in the direction of the incident ray. So I have to take this image distance as positive. And in case of convex mirror, same convention is applied. In the direction of the incident ray, all the measurements are taken as positive, and in the opposite direction, all the measurements are taken as negative. Here one more convention is that, let me rub this. All the measurements taken vertically upwards from the principal axis are taken as positive, and taken vertically downwards from the principal axis are taken as negative. What it means? If here I will draw a concave mirror, all the measurements, this is the principal axis, all the measurements taken vertically upwards from the principal axis are taken as positive, and all the measurements taken vertically from the principal axis are taken as negative. And if I will conclude the previous sign convention, which says that in the direction of the incident ray, all the measurements are taken as positive, and in the direction opposite to the incident ray, are taken as negative. So here we conclude the sign convention relating the spherical mirrors. I think this is the enough for today's class, and I hope you all understand well. Please comment your reviews in the comment box so as I could more upgrade my lectures and I could clear your doubts more clearly. So Allah Hafiz, take care of yourself and your parents.